Hello everyone and welcome to yet another video. And listen, recently I've been talking a lot about code and I've been mentioning a lot of things which are not actually properly explained on this channel. So today we will summarize everything you have to remember about memory. Without any further ado, let's get into it. And so today's entire video will be about the difference between the addresses and the values. Now, in order to explain the topic well, you'll have to imagine that you're an ambitious computer scientist and you're working on the very first computer, and you have to create a memory system. Now, as scary as it may seem, it is actually pretty simple. When you have bytes, about which I talked a lot of in my previous 3 videos, then you need a system for storing multiple bytes. And so you do the simplest thing and you just stack them next to each other. Pretty reasonable. And believe it or not, this is not a reference to CGP Gray's rules of the universe, which basically say that the solutions that are the first thing you think of, look sensible and are easy to implement, are often terrible, ineffective solutions which will cause suffering, because this is actually how modern day computers work. That is obviously in RAM, but bytes are just stuck next to each other. So yeah, there we go. The system should be working correctly. But there are still a few hiccups that I think you should solve. Now, one of these hiccups might be saving a value. For example, if a user saves a value, let's say that the user will change it to 613, then how do we tell the user where to access it? Well, it's actually a relatively simple problem. We know in which byte the user saved the value, so we just index them and tell the user here, the value saved is in the byte number 1. Now, another problem you might run into is what if user saves multiple values? Now you may obviously ask, but make it, isn't that the exact same scenario? Can we just handle it in the exact same way? Well, not really, because handling it in the exact same way would be quite inefficient. Why? Well, it's because those indexes that tell you which byte user saved the value in, for example 234, really often in RAM are not 234. I mean, think about it, you probably have right now on your machine gigabytes of RAM. Gigabytes means billions, right? So you have billions of bytes, which means this will not be 234, it will be billions. Which means you'll have to save 3 large numbers. But wait, why is that a problem again? Why is saving 3 large numbers a problem when saving 3 little numbers is not? Well, I mean, think about this. Each of those bytes is a binary number. It has 8 binary digits, which basically means it has 8 numbers that are either 0 or 1. Just like any number from 1000 to 9999 requires 4 decimal digits, every byte requires 8 binary digits. But there is a problem because 8 binary digits can only express from 0 to 255, which means in order to express a number that has billions, you would need 8 bytes. Which means in this scenario, if you would like to save 3 bytes into RAM, basically you'll tell your program to do something like this. Well, you see, we have those 3 bytes, but there are too many for your processor to store right now. So instead we'll just save them into RAM, the random access memory. Now, in order to access those bytes again, though, we will need to remember their addresses. So instead of storing these 3 bytes, we'll store their addresses, which have 24 bytes. Pretty inefficient, right? So what can we do instead? Well, what we can do is, if we go back to our first example, we can just store one address, the address of the first thing in our array. And then, well, we should know as a programmer where everything is relative to that first value. Now that is the offset, because we have the original value and then we offset it by a given amount. This will not work, for example, because not gonna lie, storing only 3 bytes is kind of trivial and not really efficient. But if we were storing something like 20 bytes, it would work, because then for our 20 stored bytes, all we have to remember is just 8.